Start.
Hi everyone, our presentation topic is exploring the limits of transfer learning with unified text-to-text transformer. It's basically a transformer model with few changes. Next slide, please. The main modification that T5 model has made to the standard transformer is text-to-text framework. It basically converts every problem in a text-to-text based problem means taking input as a text and giving output as a text. Like earlier, few problems like classification and other text generation problem were separately trained, but this model gives a uniform framework for all such problems. And the another change that it has made is layer normalization adjustment. Normalization is done inside the layer actually, and it does outside of it. And the bias term is removed in this to simplify the overfitting problem. Now there is the problem of overfitting is reduced in this, and and another change that is made in this is relative position embeddings. In the standard transformer, there is a fixed position embeddings, and it uses the relative position embedding, which enhances the flexibility in making the relationships with tokens. And and the last change that has been made in this model is the weight sharing. It actually shares the weights between input and output embeddings, which makes it a robust model, and which also help in reducing the parameters. Next slide, please. Next, the data set that has been used to train this model is called the C4 data set, and it basically contains the text from the internet, and which is in the raw form for the pre-training purpose. That was in the raw form only, and that cleaning and other things happened later. And the originally the data set was 20 TBs, and in the clean form it was 750 GB. And that was used for the training, and it has also been added into the TensorFlow data sets. Um, the clean data set was used for the unsupervised in an unsupervised environment. And that's all. Next,
Channel.
Janil.
Channel भाई.
हेलो हेलो आवाज नहीं आ रही क्या?
स्टार्ट कर भाई तेरा पार्ट.
हेलो
आ रही है भाई आवाज.
अच्छा तो बोलो तो सही. ऐसा ही बोल रहा
स्टार्ट
था
कर
मैं.
ना.
Key benchmarks and tasks used in this paper are glue and super glue. Glue is used for glue is mainly used for tasks like sentence accessibility judgment, sentiment analysis, paraphrasing, sentence similarity, and super glue is used for natural language inference, conference resolution, sentence completion, word sense disambiguation, and question answer. And machine translation is another part which is which also a task which is benchmarked by the benchmarked in the paper. And and use it uses common crawl, news commentary, and European datasets for benchmarking apps. And CNS daily mail datasets are used for abstract summarization, benchmarking, and Squad is used for Q&A answering. Next. And the paper focuses on unified format for diverse NLP tasks such as text tracks format in which both input and output are in text format. And there are also examples like input we want to translate from English to German, so input is given in text, and it will give output of the text in German. And there are also task specific details such as classification task, uh, in which we predict single output labels and based on input sequence. Then we have regression task, which, for example, similarity test, and conference resolution, in which we predict, means if there are words ambiguous, for example, they in the city council refused the demonstration of permit demonstrators a permit because they feared violence, which would be predicted as the civil councilman. It should be they in that way. Then adaptation to various benchmarks, which I already mentioned. And model training and fine tuning. In model training and fine tuning, maximum likelihood objective is used for training, and specific tasks prefix is added to input sequence to inform model of the desired output. And the accuracy of the predictions against the benchmark means it will output and evaluate the accuracy against the benchmark standards. Next.
So author has explained before like what the T5 model is about. It's mostly like using text-to-text framework, which is like following objectives: translate objective and cola sentence, STSP sentence, and summarization. Uh, the translate sentence as they use a prefix word for each objective to perform the task by the model. And in the model architecture, the author has primarily used the transformer implementation as proposed in the 2017 paper by Vashani et al. And in the in this architecture is different a little bit from the original in the way that they have removed the additive bias from the layer norm, and they have used relative positional embedding instead of absolute positional embedding. Uh, and the architecture has been tested on a few different uh, objectives. First was denoising, second was language model, and the architecture uh, is also like expanded and tested on uh, the author has explored different architectures to see which one fits better as per the use case that they were proposing. Uh, the first architecture they have tried is with like in this table you can see they have tried five different architectures: encoder decoder with shared parameters, same with this half the layers, and language model and prefix LM. So they have seen that in this architecture they have found that shared parameters and encoder decoder architecture perform well, but since the first one, that is the baseline model encoder decoder model, was using too much compute, they decided to go with the shared parameters one. They have used three different modular architecture variants in this. The first one was fully visible mask. Second one was with causal mask, and third one was with causal mask with prefix. Each fulfill a different purpose of pre-training objective. Fully visible mask is used when you for like prediction tasks, when you need require the full uh, context during prediction. Causal mask is mainly used for language models, which are generative in nature, and the causal masks with prefix with used in prefix language model you that try to predict the classification of a sentence on other thing and something similar. They have mainly explored three unsupervised pre-training objectives. First one was span corruption, in which they mask the words in a sentence and try to reconstruct those missing spans. And second one was prefix language modeling. They split the sentence into components, and one is used as an input to the encoder, and the other is the target sequence to be predicted by the encoder, which can be seen below in the table. And the last one was reshuffling objective, in which they shuffled the input sequence and asked the model to restore the correct order. Uh, in these unsupervised objectives, they saw that the bird style objective, that was the masked and span corruption objective, it was the one that performed best on the different benchmarks that author explored. So they decided to go with the replace corrupted expense uh, as it shows the most promising mm, results. And he also explored this further by changing the corruption strategy, the corruption rates, and the corruption length, in which he found that replacing the spans and changing the corruption rate by 10 to 50%, the uh, prediction uh, prediction rate drops significantly when it increases to 50%, as if you do not have the enough input context to predict the correct output. So they decided to go with the 15% corruption rate, and in different corruption length, corrupted span length, there wasn't much change that they were observed. So they decided to go with the 2 and 3 span length.
Uh, to check the limitation of the transfer learning, they did a lot of experimentation with data set and different setups. In the past, they tried different data set. First one is C4 data set, which they got from the common crawl, and they filtered it with different heuristics. And they also tried the unfiltered version as well to check how well they filtered the heuristic works, and to check that when they uh, experimented with different tests, they found that it performed very badly, poorly in all the different tests, which we can see in the screen. Apart from that, this obviously tells that this filtration part is very essential for model training. Also, it from inspired from different papers, they choose some domain-specific data, like some news kind of data, some web text. They also did Wikipedia data, but they said this Wikipedia is just represent a specific domain of language, which is this articles or encyclopedia articles. So they also added this Toronto book corpus, which is nothing but just uh, data from all ebooks, and they also train model on those. From this section, we can see that from some particular test, domain-specific data set worked better. So we can see this in some kind of uh, scenarios, the domain-specific data set can outperform diverse data set. Next, what they did is instead of using full data set, they used some subset of the data set, but they repeated some number of data set and just checked how repetition of data works. They realized that as the repetition is increased, here we can see 0, 24 times, 256 times, and going on, the performance of decreasing. Uh, Here you can see that the more we repeated the data, the model got overfitted those data, due to which the test output was very poor. And but some small amount of repetition is fine, which we can see for 2029, and the full data set, the variation is not that much. They also tested some different fine-tuning techniques. So these are two different techniques they did. One was they added one adapter layer after every feed-forward layer. So adapter layer is nothing but it has two tens projection layer and a non-linearity for which they use ReLU. So here the first for feed-forward network down project the vectors, then it passed it through a non-linear layer and then again up project. So the output and input vector size is same. So there is no additional changes required in the model. And here the goal was just to train only this adapter layer and a layer normalization instead of the whole each and every parameter during the fine tuning. And then there was another technique they used was gradual unfreezing, where in the initial state they unfreeze the final layer of both encoder and decoder, and it's after a certain time step they slowly unfreezed other layers too, and in that way time by time they unfreezed each and every layer and they trained the model like that. To see how those worked, they saw that the gradual unfreezing was not that much good compared to all parameters training. Uh, then the adapter layer part, there was additional hyperparameter, which was the dimension of the projection. They tested with different and then found that for some D it worked good and for some it didn't. But overall, training all the parameters was better. But of course, this is computationally expensive. Then they also did multitasking training for which they created some different data set. So for that, the first was equally taking the samples from all the data set of different tasks. Then they thought that not all tasks require same number of data. Some tasks are. Am I audible? So am I audible now?
Yes, yes, carry on.
Nirmal, am I audible?
Yes, yes, definitely carry on.
Uh, Nirmal, am I audible?
हाँ audible हो आप
Okay,
carry on
okay.
करिए.
Thank you. So yes, so the next what we did is instead of taking equal samples of data, we took data depend on the sample size. For example, some data for some tasks are very complex. For that, we have taken larger data set, and for easy task, we took smaller data set. But for that also, there are some data sets which are very large, and if we take proportional from there, then the those data set might dominate the entire data set. For example, for unsupervised learning. So for that reason, we defined a k value, which was the maximum sample of the. So it was a limitation that we cannot take more than this much of data sample size, and we tried with different k values, and we saw that for a certain k value, which was 2018 and 2019, the model worked fine, but any value less than or greater than that, the model was not performing that good. But some task, higher K level was working fine. For example, in translation cases, where you can see that might be these tasks are very difficult to learn, so we need a lot of those data to train the model. Then we again used another technique which included temperature. So this t value is like if it's one, then this will be taking a lot of data from higher data set with the larger sample, and if we increase the t value, it eventually be equal to the equal data proportion. And we also tested for those. And apart from that, we also did training. We used different training strategies. One was the unsupervised pre-training plus fine-tuning, which was the you actually used for base model. Then we also just trained using multitask training, where we just did a multitasking training and used those model directly on different tasks. Then we did multitasking pre-training plus fine-tuning, and also. The author of the paper said that if when we are doing multitasking, it is possible that the model will develop a general skills, and it can be used for fine tuning or for a task that it never shown in the find pre-training part. So for that they did leave one out, multitask training. In that, during the fine pre-training, they just leaved one task out, the data of one task out, and they fine-tuned with those particular tasks, and they tested the model. Apart from that, they also did supervised multitask pre-training, where they just removed the unsupervised data and just pre-trained with supervised data. And they said they saw this that for a lot of tasks, the supervised multitask pre-training was working fine, especially for the translation part. This tells that for translation, we don't need actually require a lot of data, English data for pre-training, because translation tasks include both English and some other language data. And yes, and the fine tuning after both multitasking and unsupervised pre-training worked good for in both of the case. So that's why they choose multitask pre-training and fine tuning, and after that they fine tuned with a particular task. They also tried to scale the scaling, where they use different model size and different training steps. So initially they did one same model size with 4 training steps, and they also did with different batch size. And they also scaled the model size where 2x and 4x. They also tried different assembled technique, where they trained 4 different models, and they also did they trained one single model for pre-training, and then fine-tuned on a different data set to make it 4 different models. For that, they saw that just assembling 4 different models from the base was working better than just fine-tuning. And also this that scaling of the model size improved the prediction, the score in the different tests. So after all this experiment, they finally decided to go for a longer training, due to which they also try to fetch more data. Then they did multitask pre-training instead of just unsupervised pre-training, and also they fine-tuned on specific task data for better result. They also did beam search for generating test, and these are the different model size they used. They created a small model which was 60 million parameter, then base model which were 220 million parameter, then large model which was 770 million parameters, and 3 billion and 11 billion parameters model. So yeah, Nirmal.
So now in this section, we summarize the important findings from the study and suggest possible direction from the future research. First one, taking text-to-text format. The text-to-text format used in this paper is simple and effective way to handle many different types of language tasks like translation, summarization, and classification. By converting by converting every task into a text-based problem, both input and output are text. The authors could use the same model, loss function, and training approach for the everything. Deposit being simple, this method worked well and even produced state-of-the-art results when applied to the large models. Second one is architectures. The authors tried different variation of the transformer architecture and found that the original encoder-decoder model worked best for the text-to-text task. Even though the encoder-decoder model has a more parameter than a simple model, like a bar, which used to just encoder part, it had a simple computational cost. Sharing the same parameter between the encoder and decoder to save the space didn't hurt the performance much, but half the number of parameters, making the model lighter. Third one is unsupervised objective. The different unsupervised pre-trained objective way to train the model without label data, while the performed similarity when they focused on the fixing randomly corrupted text. This is called a denoising objective. The author recommended using objective that generate shorter output sequences
during training because they make training faster and more efficient. Fourth one is the data sets. The author created a new data set called Colossal Clean Crawled Corpus C4, which contain a massive amount of clean text from the website. And they found that using in-domain data, specific to the task, like Wikipedia data for reading comparison task, can help improve performance for a certain task. However, using in-domain data limit the database dataset size, which can be disadvantage. Training the small dataset that repeat themselves during the training can make performance worse. This shows the importance of the using large and diverse dataset like C4. Next slide. Sixth one is the training strategies. The author found that the updating all the parameters during the fine tuning after pre-training work better than model that only updating some parameter, although this approach is more computationally expensive. This also experimented with the multitask learning, trained on a multiple task at once, which is done by the mixing data from different tasks. However, they couldn't find a good strategy for mixing tasks like work better than pre-training on a general dataset first and then fine tuning on the individual task. Scaling. The author explored several strategies to improve performance by using more computational power, including training on a more data, using larger data set, and training larger model, adding more layer and parameter, uh, assembling, combining multiple model to work together. They found that larger model generally perform better even when trained on a fewer step than smaller model. Assembling model combining multiple model improved performance significantly, but only if each model was pre-trained and fine-tuned separately. Uh, Last one is a pushing the limits. Combining all their findings, the author trained model up to 11 billion parameter and achieved state-of-art result across many tasks. The model was trained on a 1 trillion tokens of huge amount of text using the C4 dataset and denoising objective. They made their code dataset C4 and pre-trained model publicly available to help others build on their work. Next slide. So we are now see the future direction and challenges. The challenges of the large model is it can uh, large model tends to better performance, but they can more expensive to run. As hardware becomes cheaper, it will likely become easier to use large model. However, in some cases like running model on a mobile device, smaller models are necessary. Smaller models are also useful in a low resource task with little data and limited computational power. So more research is needed to make smaller, cheaper model that still perform well. Second one is more efficient knowledge extraction. The author note that the model used in this paper for pre-training denoising test may not have a most efficient way to teach a model general knowledge. They suggest exploring more method that could pre-train model more efficiently without needing train on a 1 trillion tokens of the text. For example, training a model to recognize real versus machine generated text is a more recent efficient approach. Third one is a task similarity. The author observed that training on in-domain data in a similar task helps improve performance, but this can find was based on a general assumption like using Wikipedia data for a task based on the question from Wikipedia. They suggest creating a more formal way to measure how similar different tasks are so that the researcher can make better decision about which dataset to use for pre-training. This could also help in selecting supervised pre-training tasks, which has been shown to improve performance for certain benchmarks. Last one is a language agonistic model. The author was disappointed that English only pre-trained didn't achieve the best result for language translation tasks. They want to create a language agnostic model that can handle multiple languages without needing separate model or vocabulary for each language. This would make the model more universal and practice for the larger number of the users, especially since English is a not native language for the most of people worldwide. Next, I think this is the last slide. Thank you.